Hey everybody, Mrs. Bixler here. This is our last section of factoring, which is super exciting. But now we're going to use, well, after this section, we're going to use all this information to start to actually solve equations, which is even more exciting. So we're going to talk in this video today about two special polynomials that you already know about, perfect square trinomials and difference of two squares. If you don't know what I'm talking about, go and rewatch that 10.4 video from the other day. So these should look familiar to you. On the left is a perfect square trinomial, and on the right is the difference of two squares. So we're going to talk about when you see these kinds of things, you're going to be able to factor these as well. So first I want to talk about sort of identification. So how do you know that something is a perfect square trinomial? So if you remember from the 10.4 video, the way that we get a perfect square trinomial is we take something that is being squared and we FOIL it out. And when we FOIL it out, we get this perfect square trinomial. So the way that we know this is a perfect square trinomial is this is a perfect square because the square root of x squared is x. This is a perfect square. So the square root of this guy is 3. And then this middle number is twice x times 3. So 6x is twice x times 3. And then all you do is you see that that x and that 3 are in that initial problem. Cool? So that's how you figure out if something is a perfect square trinomial. So let's look. I've got 4 right here, and I want to decide if these are perfect square trinomials. So this first one has got to be a perfect square, and so does the second one. So the square root of x squared is x, the square root of 25 is 5, and then look, this is twice x times 5. So this is a perfect square trinomial. But if you look at the next one, oh, this is a perfect square, amazing. This is also a perfect square, amazing. But shoot, 12 is not twice x times 5. So this one is not a perfect square. All right, let's look at the second one. Or sorry, the third one. So this guy is x. The square root of this guy is 6. So we've got two things going for us, which is great. And then look in the middle. Is 12x twice x times 6? It is. And I know it's negative, but that's okay. Don't worry about signs right now. So the fact that it's a negative 12x, that's okay. It's still twice x times 6. So this would be a perfect square trinomial. Now let's look at the last one. So the square root of this guy is x. The square root of this guy is 100. Great. We've got two perfect squares. Sorry, the square root of that one, whoop, is 10. So look at the middle though. Is this guy twice x times 10? No. So this is not a perfect square trinomial. So if I gave you a problem that looked like this and I asked you to factor it. So I'm looking at this and I tell myself, okay, maybe this is a perfect square trinomial. That's kind of cool. So let me just see. Oh, the square root of x squared is x. The square root of 81 is 9. Amazing. And oh, this middle term is twice x times 9. Awesome. So if I were to factor this, this is how easy this is. You just take the x and the 9 from here, and then you see how this is a negative? Boom. You're done. Now, in a worst case scenario, do not freak out. If you are looking at this and you're like, maybe it's a perfect square trinomial, I'm not sure, you can go old school here. So if I looked at x squared minus 18x plus 81, let's do this the way we've done our previous factoring ones. What are factors of 81 that combine in some way to get me a negative 18? Well, 9 and 9. And I'd have to do a negative 9 in order to get negative 18, right? So we'd make our two little parentheses and we'd get x and 9. And I know they both have to be negative. Wait a second. I've got two x minus 9s, same thing as what's above. Cool. So again, this is sort of like a worst case scenario. You can just do your plain old factoring and you wind up finding out it's the exact same thing. And you're going to be like, it was a perfect square trinomial. Okay, second one. This is the difference of two squares. So we've got these two binomials that look super similar to the ones that we did in section 9 or 10.4. And when we FOILed them out, we figured out that we got x squared minus 9. So if we look here, oh, look, I've got the square of this number and the square of this number, and then I just subtract them, and that's it. So let's see how we know if something is the difference of two squares. So this guy is a perfect square, check. This guy is a perfect square, check. And I'm taking the difference of them. So this would be the difference of two squares. All right, let's try it for this one. Is this guy a perfect square? It is. Is this guy a perfect square? It is. But shoot, we're finding the sum of them. So that's not the difference of two squares. Done. Not a difference of two squares. All right, let's try the next one. This guy perfect square. Whoop. This guy perfect square. Yes. And we're finding the difference. This is the difference of two squares. Now pause the video and tell me if the next one is going to be the difference of two squares. All right, hopefully you told me no, because this is a perfect square, but this guy is not. Ah! So it is not going to be the difference of two squares. All right, so now let's try this one. And I want you, let's do this guy. I want you to try and factor this. What are the two binomials that you had to multiply together to get this? Pause the video and then come back. All right, so hopefully you saw the square root of this guy is x, the square root of this guy is 5. So I know I'm going to have my two binomials here, and one's going to be x plus 5, and one's going to be x minus 5. And you're done. All right, so remember how we talked about when we factor, we talked about step 1 and step 3, right? You first ask yourself, is there anything I can take out of each term? And then if the answer was no, then you just go into plain old factoring. But now we've just snuck in this second one. And the second question is going to be, is this thing the difference of two squares or a perfect square trinomial? So let's do a few of these together. Let's look at this first. So is there anything I can take out of each term? Do you have like a 2 that you could divide out? Or do you have like an extra y or something that you could divide out? Nope, doesn't look like it. All right, the second question, is this going to be the difference of two squares? No. Ah, is it a perfect square trinomial? Maybe. Well, let's see. This is a perfect square. This is a perfect square. And wait a second. This is twice that times that, the x times the 4. So this winds up factoring into x plus 4 squared because it is a perfect square trinomial. And then remember, old school, if you don't know that and you don't remember that, think about what are factors of 16 that combine in some way to get me an 8. It's going to be 4 and 4. So you're going to have x plus 4 times x plus 4. Oh, wait, I've just written x plus 4 twice. I know that's going to be x plus 4 squared. All right, now let's try this next one. So first question is there anything I can take out of each term? Nope, doesn't look like it. Is it the difference of two squares? There are two things there. So let's see. So the square root of this is y, the square root of this is 11, and we're taking the difference of it. Yes, this is the difference of two squares. So the factored form here is going to be y minus 11 times y plus 11. Weird y there, but whatever. All right, next one. I want you to try this one on your own. So pause the video, ask yourself that first question. Is there anything I can take out of each term? All right, you're back. Hopefully you saw that you can take a 3 out of everything. So you're left with x squared plus 20x plus a hundo. So we have done that, but this is not fully factored, so we are not done. So let's keep asking ourselves these questions. Is it the difference of two squares? No, because I'm not subtracting anything. Ooh, is it a perfect square trinomial? Maybe. Let's see. So this is a perfect square. This is a perfect square. And this right here is twice x times 10, which means this factors into x plus 10 squared. I know this is a positive number because of this plus in the front here in front of the 20. But then don't forget, you've got this 3 that you've got to bring in front. And this is your final answer. All right, I'm going to give you this one now, and I want you to try this on your own. All right, we're back. Hopefully you saw that you could take a 2 out of everything. X squared minus 16 is what you're left with. And then lo and behold, This is the difference of two squares. And you should have gotten x plus 4 times x minus 4. But don't forget that 2 out in front, and you're done. All right, one more, and then I'm going to let you go. Let's try this one. All right, so is there anything I can take out of each term? No, there's nothing. All right, is it the difference of two squares or a perfect square trinomial? Well, no, it's not the difference of two squares because this isn't a perfect, or this is not a perfect square, right? 39 is not a perfect square, so it's not the difference of two squares. And then plain old factoring, well, I can't do that. It's not a trinomial. So this is CBF. This cannot be factored. All right, so that is all the information for 10.8. Go ahead and tackle the worksheet. Good luck.